Okay, we are studying what is that aromatic chemistry. In that important compound is benzene. So far, I have been explaining complete chemistry of benzene. That means we studied aromaticity, preparation, chemical properties of benzene. All those things we have discussed so far. But regarding this, there is some short topic. What is that? Characteristics of aromatic compounds. So simply there are the special properties exhibited by aromatic compounds unlike other organic compounds in organic chemistry. So see characteristics of aromatic compounds. Characteristics of aromatic compounds. So see here, particularly aromatic compounds have unique properties. That means they got some specific properties unlike other organic compounds in organic chemistry. అంటే ఇక్కడ నేను ఏం చెప్తున్నా అంటే వాట్ ఐ మీన్ టు సే, మిగతా ఆర్గానిక్ కాంపౌండ్స్ ఉంటాయి, మిగతా ఆర్గానిక్ కాంపౌండ్స్ లాగా కాకుండా అరోమాటిక్ కాంపౌండ్స్కు కొన్ని ప్రత్యేకమైనటువంటి ఒక యూనిక్ ప్రాపర్టీస్ ఉంటాయి. అవి ఆ యూనిక్ ప్రాపర్టీస్ ఏంటివో అవి మనం డిస్కస్ చేద్దాం. సో యాజ్ యూ నో, ఐ థింక్ బికాజ్ we are studying, I am explaining such properties. What are those? Aroma means, particularly in Latin language, aroma means having sweet smell, nothing but sweet odor. Aromatic compounds, they have aroma odor, nothing but sweet odor, just like perfumes. Nice. They have smell like perfumes. Okay. So aroma means sweet odor, nothing but. Then moreover, we know aromatic compounds burnt with sooty flame during combustion. These compounds burnt with sooty flame. అంటే ఎప్పుడైతే మనం తగలబెట్టినప్పుడు ఏమైతుందంటే మసితో కూడిన జ్వాలన వస్తాయి. జస్ట్ టైర్లు తగలబెడితే బాగా ఏమవుతుంది, మసితో కూడిన జ్వాలలు వస్తాయి. బట్ when come to the part of aliphatic compounds also alkynes also having combustion nature, they also burnt but without sooty flame. That is the major difference. Aliphatic compounds having combustion nature, even aromatic compounds are also inflammable compounds. But what is the difference in between these two? Aromatic compounds give sooty flame while burning. Yes. But whereas aliphatic burnt without sooty flame. That's why butane, we are using cooking gas. LPG and butane. Liquid petroleum gas, LPG, all those things we are used as a domestic fuels. ఇక్కడ మస్తో ఉన్నటువంటి జ్వాలన రావు. ఎందుకు స్మోక్ కాక వస్తే ఏమైందంటే smoke, it is when smoke entered into our body, that damages our cells. Sometimes it causes cancer. So that thing you remember. So here what I am saying, aromatic compounds burnt with sooty flame, whereas aliphatic compounds burnt without sooty flame. This is the major difference to remember. And then next point, aromatic compounds having more boiling and melting points, and aromatic compounds which are not soluble in water, insoluble in water, but freely soluble in organic solvents like petrol, diesel and chloroform, ether, like that. The aromatic compounds అనేవి అసలు వాటర్లో కరుగుతానికి స్కోపే ఉండదు. aromatic compounds, కొన్ని ఆర్గానిక్ కాంపౌండ్స్ కరుగుతాయి, aromatic compounds మాత్రం కరగవు. అది ఒక క్యారెక్టరిస్టిక్ ఫీచర్. దెన్ aromatic compounds, you know, most of all aromatic compounds are cyclic compounds. They contain maybe benzene rings or non-benzene rings, but having cyclic structure is the mandatory cyclic structure, and that cyclic structure should be planar. What I mean to say planar means all the carbons in that ring which are lies in the same plane. That means they can have planarity and also ring structure. In that conjugation double bonds are present. That means alternate double bonds are present. Moreover, you know those pi bond electrons present in aromatic compound, those are not static, those are oscillated or delocalized from one place to other place. That phenomena we call as modern recently and latestly we call as resonance. So that means all aromatic compounds having the unique key property to exhibit resonance. Due to involvement of resonance phenomena, due to presence of resonance, all aromatic compounds are stable. So though that's why all aromatic compounds are involved in electrophilic substitution reactions very easily rather than addition and oxidation reaction. Already we have seen and studied such reactions. Yes. And all the aromatic compounds must and should obey Ukel rule. Yes. What do you mean by Ukel rule? 4n plus 2 pi electron system. In that, n is an integer. And we discussed at the beginning of our class, aromat, under topic of aromaticity, we have seen so many Ukel rule compounds. Okay, and aromatic compounds are toxic in nature. They causes cancer. The property of causing cancer is nothing but carcinogenicity. Yesterday we discussed. And among aromatic compounds, the best and mother aromatic compound is benzene. So we studied entire chemistry of benzene. By using benzene and its derivatives, nothing but aromatic compounds, we can synthesize several compounds in industry, several compounds. That means aromatic compounds have got much importance in our daily life. Why? Because they are used to prepare dyes, drugs, and plastic materials. And these benzene and derivatives are used as a good solvents in several organic reactions. These are the main characteristics of aromatic compounds. Now you write down aromatic compounds having aromatic compounds having unique key properties like number one, these are sweet odor compounds, like perfumes. Here, you know, aroma means the word aroma, it can give out the meaning. Aroma means pleasant smell. Pleasant. Aroma odor means pleasant. These are burnt with sooty flame on combustion. These are all aromatic compounds. These are possessing more or more boiling point. If it is liquid, possessing more boiling point. If they are solid, like naphthalene, Okay, so these are possessing more melting and boiling points. These are insoluble in water. Aromatic compounds are insoluble. These are insoluble in water but soluble in freely soluble in organic solvents like ether, chloroform, petrol, etc. Okay, these are toxic in nature. These are toxic in nature, mainly fused polynuclear aromatics cause cause tumors, cause cancer in human body while consumption. Okay, then sixth one. This property of causing cancer is called what? Carcinogenicity. Carcinogenicity. Okay. These are cyclic compounds. These are cyclic compounds. These are cyclic compounds. These are cyclic compounds with planar property. Understood? With planar property. Planar property means you know this, all the carbon atoms present in same plane with planar property. These are cyclic compounds with planar property in which conjugated double bonds are present. In which conjugated double bonds are present. In the sense conjugated double bonds are present in the sense pi bond. Yes. Pi bonds. Alternate pi bonds. Okay. Conjugated double bonds means alternate pi bonds. Alternate pi bonds. Okay. Then next point. They obey Ukel rule. They obey Ukel rule means having 4n plus 2 pi electron cloud in which n is an integer. In which n is an integer. N is equal to 0, 1, 2, 3 dash dash. Okay. Then next point, eighth point. Pi electron cloud in aromatic compounds, in AC, aromatic compounds is not static, which is delocalized, throughout the molecule. Understood? Throughout the molecule, which is known as Resonance. What that property is called?
Resonance.
Throughout the molecule, this property is called this property is called resonance. This property is called what? Resonance. See, all aromatic compounds, all aromatic compounds involved in resonance, that means exhibit resonance, exhibit resonance. So they are stable. They are stable compounds. They are stable compounds, isn't it? They are stable compounds. Okay. Due to their unique stability, due to their unique stability, these compounds easily, these compounds easily involved in electrophilic substitution reactions. In electrophilic substitution reactions rather than addition reaction. Understood? Rather than addition reactions. Rather than addition reactions.
Yes.
These are useful to synthesize a pharmaceuticals, B drugs, C dyes and pigments, D different types of organic intermediates, fertilizers, plastics, used as solvents in several reactions. These are the uses of aromatic compounds. Understood? These are useful to synthesize pharmaceuticals, drugs, dyes, pigments, different types of organic intermediates, fertilizers, plastics, and also different solvents. These are the characteristic features of aromatic compounds you have to remember. Okay? Then, now we practice some resonance structures, important resonance structures of aromatic compounds. Write down. Practice of resonance structures, structures of monosubstituted, mainly monosubstituted benzenes. Okay, this is also very important, and you should practice so that you got much knowledge regarding aromatic chemistry. So then we want to write the first one. Phenol properties. Of course, not phenol. Halobenzene properties. See halobenzene. Halobenzene. Halobenzene resonance structures. RS means what? Resonance structures or resonance forms. Okay. See, look here. You know, whenever you want to write resonance structure, just you can follow this style. Halogen means having what? Non-bonded pair on it. It releases electron pair into the nucleus, nothing but what? Plus M effect.
Plus M effect.
So whenever it is plus M effect, simply it is called OP director. This thing, orthopara director. So you will get resonance forms like this. So it is shifted to this place, immediately it's shifted to this one. So here X attains plus charge, no?
Yes.
Why? Because it donates electron pair.
Yeah.
So there is a loss of electron density. That's why it acquires plus charge. Here this pi bond shifted to this place, so it is negative. Okay, this is structure one, resonance form one. You remember.
Okay.
Then after this, alternate shifting. Okay, here this minus move like this because electron is a charged particle.
Of course.
Charged particle. That's why it move from one place to other place. తిరుగుతూ ఉంటుంది, మనం ఏం తిప్పం.
Yes.
మనం ఏం తిప్పం, అది తిరుగుతూ ఉన్న దాన్ని చదువుతున్నాం అంతే.
Yes.
ఓ టీచర్ ఏం చెప్తా అంటే ఇది ఈడికి తిప్పు, ఇది ఈడికి తిప్పు, ఇది ఈడికి తిప్పు అని మనమోరం తిప్పడానికి అసలు ఎలక్ట్రాన్ కనపడుతుందా? అవునా? తిరిగే అది అది చేసేటటువంటి చేంజెస్ని మనం గమనిస్తున్నాం. ఓకే, ఇదంతా కూడా మైక్రో ఎడ్యుకేషన్, ఇదంతా మైక్రో స్టడీస్. దిస్ ఈజ్ స్ట్రక్చర్ 2. దెన్ స్ట్రక్చర్ 3. Okay, after that what happens? This minus shift towards this, and pi electrons go into same place. Isn't it? This is the RF, resonance forms. Resonance structures are resonance forms of what? Halobenzene. Okay, then you should practice today itself. You will practice what? Instead of X, okay, you take chlorine, bromine and iodine. In place of X you put chlorine. Write chlorine resonance structures. Bromine, bromobenzene,
Okay.
iodine. This is halobenzene, no?
Yes.
If you place chlorine here, chlorobenzene, bromobenzene, iodine. Like that, you have to practice 3 other compounds.
Okay.
Then I want to write another one. Phenol resonance forms. Phenol resonance structures or resonance forms, whatever it. Then we are going to write phenol resonance forms. This is nothing but what effect? Plus M. Plus M means which director? OP director. This phenol. These are the resonance forms of phenol, you know.
Yeah. Okay.
Completed. Then here I make a small change here. See what is that? Anisole. You know anisole. Third one, anisole. Anisole means, you know what is that anisole? Look here.
Sure.
Anisole means in place of HCH3. This is anisole. You know.
Yes.
Okay. Anisole. Completed. Anisole resonance forms. Just in place of hydrogen, you put CH3. This is anisole resonance forms. Right on. How many we practiced now? See, this is 1, 2, 3, 4, phenol 5, this one 6. Okay, 6 resonance forms. All are what? Plus M effect and OP directors. Look here, this is aniline, no? NH2 means NH2 group on benzene, that is aniline. So it is also plus MF to OP direct. Okay, already we write what? Come on, we write down. This is fourth one. Completed this one. Okay, this is nothing but what? Toluene, you know.
Yeah.
Here, what happens? Temporarily, this bonded hydrogen bond electrons releases into the benzene nucleus, by which you are getting structures whose contain electron density ortho and para. These resonance forms are called no bond resonance. No bond,
Resonance.
nothing but what? Hyperconjugation phenomena. Okay, no bond resonance forms. I already told you, know, under electronic effects.
No one resonance. Finally, completes. Completes.
Completed, no? See, sixth one, I told you, sixth one. See, I take ethyl benzene resonance form. See, look here. Ethyl benzene resonance forms. Ethyl benzene means CH2CH3, no? So CH2CH3 means this is CH3, no?
Okay.
CH3 CH2. Understood?
Yes, sir.
This is CH3. Okay, this is CH3. Okay, ethyl benzene. This is CH3. This is CH3. Understood?
Yes, sir.
Over. You write down. క్లియర్.
Yeah. Yes.
నేను చిన్నగా ఏంది హెచ్ని సిహెచ్ చేసిన కానీ నేను చేసినట్టు నువ్వు చేయలేవు. నువ్వు రాయాలి. నువ్వు రాయటం కరెక్ట్, నేను ఇట్లా చెప్పడం కరెక్ట్, నువ్వు అట్లా రాయటం కరెక్ట్. నువ్వు నీ స్టేజ్కి నువ్వు అట్లా ప్రాక్టీస్ చేస్తేనే పర్ఫెక్షన్ వస్తుంది. దట్ ఈస్ సిక్స్త్ వన్. ఓకే, లుక్ హియర్, జస్ట్ లుక్ హియర్. ఎన్ మిథైల్ ఎన్లీన్ రెజొనెన్స్ ఫార్మ్స్. రేపు ఎగ్జామ్లో అడిగినప్పుడు ఎన్ మిథైల్ ఏందని మీరు కన్ఫ్యూజ్ కావద్దు. ఎన్ మిథైల్ అన్నప్పుడు ఎన్ మీద ఏమవుతుంది, ఒక హైడ్రోజన్ ప్లేస్లో సిఎస్ ఉంటుంది. దిస్ ఈజ్ కాల్డ్ వాట్? ఎన్ మిథైల్ ఎనిలిన్. Actually, this is aniline. NH2 is aniline. In place of hydrogen, methyl is there.
Okay.
That's why N-methyl aniline.
Okay, sir.
So, resonance forms means simply in place of hydrogen, there is a methyl group. Understood this?
Yes.
Over. Write down. All are what? Plus M effect, OP directors.
Okay.
The incoming, when such type of benzene, monosubstrate benzene, if it is involved in substitution, what happens? The coming electrophile occupy the ortho and para positions. Ortho and para position where electron density is available.
Okay, sir.
Okay, OP products వస్తాయి. Understood this? Okay, then now we are going to practice minus M effect groups.
Okay.
Completed this one?
Yeah.
Then minus M effect compound, the best example is benzaldehyde. I think this one number, how much this number? 8 or 7?
Separate it, sir. Minus and
Minus M effect. Minus M effect resonance forms. ఎప్పుడైనా minus M effect resonance forms, in the sense which directors these are? Meta.
meta directors.
Meta directors. Meta directors. So you can take best example benzaldehyde. Okay, number one is benzaldehyde. Benzaldehyde resonance forms. Benzaldehyde RF. This is benzaldehyde, no, isn't it? Benzaldehyde. Actually, it is minus M effect. What minus M effect means?
It will withdraw the electrons on the
Yeah,
benzene.
that is the thing. Okay, here see, oxygen attains minus charge, carbon becomes positive. No, see, look here.
Yes, sir.
This is deficiency.
Yeah.
To nullify this deficiency, it can withdraw the pi electrons from benzene nucleus.
Yes, sir.
By this, you are getting structures like this. This is the resonance structures of benzaldehyde. You try to observe the resonance forms. Here, what happens? There is a electron change occurs at ortho and para. There is a reducing of electron density. When compare with these two, which position having more electron density? Meta.
Meta.
That is the thing you remember. And moreover, ring deactivating. So it involved in substitution, but very hardly when compared with plus M effect compounds. ప్లస్ ఎం ఎఫెక్ట్ కాంపౌండ్ తొందరగా రింగ్ యాక్టివేట్ కాబట్టి తొందరగా పాల్గొంటాయి. మైనస్ ఎం ఏమైతే డీయాక్టివేటింగ్ కాబట్టి అందుకే బెంజిన్ నైట్రేషన్ 60 degrees దగ్గర జరిగితే నువ్వు గమనిస్తే తెలుస్తుంది. నైట్రో బెంజిన్ నైట్రేషన్ చేసినావు 100 degrees Celsius దగ్గర చేసినావు. నువ్వు రాసినావు చూడు, బ్యాక్ పోయి చూసుకో, ఉంటుంది ఆడ టెంపరేచర్ అంత క్లియర్గా రాసి ఉంటుంది. బెంజిన్ నైట్రేషన్ రియాక్షన్ చూడు, ఉంటుంది ఆడ బెంజిన్ నైట్రేషన్. హాలోజనేషన్ అయిపోయాక ఎలక్ట్రోఫిలిక్ సబ్స్టిట్యూషన్ బెంజిన్ నైట్రేషన్లా సింపుల్ నైట్రేషన్ జరిగినప్పుడు బెంజిన్ సింపుల్ నైట్రేషన్ ఏమో ఎంత దగ్గర జరుగుతుంది? 60 దగ్గర జరుగుతుంది. మళ్ళీ నైట్రో బెంజిన్ చేసినప్పుడు 100 ఉంటుంది. అదేందా చాలా జాగ్రత్త. సరే, దిస్ ఈస్ బెంజాలియడ్ రెసొనెన్స్ ఫార్మ్స్. దెన్ బెంజోయిక్ యాసిడ్. సి సెకండ్ వన్ బెంజోయిక్ యాసిడ్. వాట్ చేంజ్ ఐ డిడ్ హియర్? సి what change benzoic acid, you know. Benzoic acid means what is the difference between benzaldehyde and benzoic acid? This just OH is there, that's it. This is benzoic acid resonance, right now. This is benzoic acid. Okay, everything is same. మల్టిపుల్ బాండ్ ఉన్న ఫంక్షన్ గ్రూప్స్ ఏవైనా ఏ ఏ ఏ ఎఫెక్ట్ కలిగి ఉంటాయి? మైనస్ ఎం.
Minus M.
ఈ పై ఎలక్ట్రాన్ క్లౌడ్ వాటంతా అవే తిరుగుతాయి, మనం ఏం తిప్పం. వాటిని అబ్జర్వేషన్ చేసినాం మనం ఇట్లా తిరుగుతున్నట్టు. ఇదంతా కూడా స్పెక్ట్రోస్కోపీ ద్వారా అర్థమవుతుంది. ఇప్పుడు నైట్రోబెంజిన్ అనే లిక్విడ్ తీసుకొని ఎలక్ట్రాన్ మైక్రోస్కోప్ మీద పెట్టి చూస్తే ఆ ఎలక్ట్రాన్ క్లౌడ్ అట్లా రొటేట్ అవుతుంది అనేది మనకు తెలుస్తుంది. ఆ ఎలక్ట్రాన్ మైక్రోస్కోప్ హై రిజల్యూషన్ ఎలక్ట్రాన్ మైక్రోస్కోప్ 1,50,00,000 ఉంటుంది. 1,50,00,000 మిషన్ మీద చూడాలి ఇది. Sulfur, which group? Sulfur belongs to which group?
Sulfur plus minus and group.
Inorganic groups, first, second, third, fourth. Oxygen sulfur belongs to which group?
Sixth group.
So that's why sulfur contains how many bonds? 1, 2, 3, 4, 5, 6. Okay. This is sulfonic acid. Okay. Then క్వశ్చన్ అడుగుతాడు, కన్ఫ్యూజ్ చేస్తాడు. ఫినైల్ డయాజోనియం రిజనెన్స్ ఫార్మ్స్ రాయమంటాడు. ఫినైల్ డయాజోనియం ఆర్ఎఫ్ minus MF meta direct, phenyl direct. Okay, with this we completed entire aromatic chemistry in detail, and also we studied without leaving a single bit. Okay, it's a big topic. You should practice number of times, you get perfection. I want to stop here. Remaining part will get in the next class.